Good morning friends. In the today's lecture we are going to discuss about the electric field intensity, and then we have to study about the electric field intensity due to a point charge, and after that we have electric flux density, electric field. These points we are going to discuss on the today's lecture. Here first of all we have to discuss about the electric field intensity. What is electric field? So first of all we have to discuss about the electric field is nothing but the region around the stationary charge has the electric field. The region around the stationary charge. Region around the stationary charge is called as what? Electric field. The space around the stationary charge, that is also called as electric field. Electric field is defined as definition is we have to say that the force per unit charge, that is E bar is equals to F bar divided by Q0, where Q0 is the positive charge and F bar is the force. That is formula for electric field intensity is nothing but what? E bar is equals to F bar divided by Q0, that is force per unit charge. And then SI unit of electric field intensity is, we have to write that SI unit is Newton per Coulomb or Volt per meter. These are the two units for electric field intensity. Then we have to write the dimension for electric field intensity. E is nothing but F dimension, F is nothing but M1, L1, T minus 2, and charge is nothing but I and T, and it gets that our dimension is M1, L1, T power here 1, minus 2 and minus 1, it is minus 3, and I raised to minus 1. It is a vector quantity. These are the points we have to remember for the electric field intensity. And electric field intensity can be deflected by alpha particles. कुठल्या पार्टिकलला इलेक्ट्रिक फील्ड इंटेन्सिटी डिफ्लेक्ट करते तर आपला अल्फा पार्टिकल कॅन बी डिफ्लेक्टेड. These points are important for the electric field intensity. Remember, only the line is what? The space around the region, the region around the stationary charge is called as electric field. We have to say that electric field charge produces in electric field surrounding the space, and then we have to consider the electric field is nothing but E bar is defined as the force per unit charge. It's an SI unit, force unit Newton, charge unit Coulomb to a volt per meter. Dimension is this one. It is a vector quantity because it is in the direction of the force, and so it can be deflected only which particle? Alpha particle. Sometimes question may be asked on that. Unit कोणत्या पार्टिकल डिफ्लेक्ट करतात किंवा region around the stationary charge is called as electric field. These points are important. Multiple choice: alpha particle, electric field, charge and dimension, and it is a vector quantity. These 4 points are important for multiple choice question. Then next point we are going to discuss about the electric field intensity due to a point charge. What is electric field intensity due to a point charge? Let us consider the point charge Q is placed at the point say O, and this separated by the distance is say small r, and so P be the any point at a distance is say small r, and having charge is considered as say Q0. Here two charges are there, plus Q and Q0 is the point charge. Q is the point charge and Q0 is the positive charge. This is considered as a positive charge. At that time, according to the Coulomb's law, the force of attraction or repulsion between any 2 point charges is directly proportional to the product of magnitude of 2 charges and inversely proportional to the square of the distance between them. So F bar is equals to 1 upon 4 pi epsilon 0 Q0 divided by r square into r cap. We have know that electric field intensity is E bar is equals to F bar upon Q0. So substitute the value of say F bar here from equation 1. And here again we have Q0 is cancelled with the Q0. It gets that electric field intensity is 1 upon 4 pi epsilon 0 Q by r square into U r cap. This is the formula for electric field intensity in the vector form. Similarly, we have to write in the magnitude, that is electric field intensity is E is equals to 1 upon 4 pi epsilon 0 Q by R square. This is the formula for electric field intensity, where if a charge Q is a positive, at that time electric field is away from the point charge, and if a charge Q should be negative, at that time it should be toward the point charge. Then we have also said that electric field intensity, it should be the maximum when near the charge, and it is placed near the charge, at that time electric field intensity should be maximum. Sometimes these derivations are asking in the examination, but in the nowadays we have multiple choice question exams. So the important points on this article is, remember the formula for electric field intensity is equals to 1 upon 4 pi epsilon 0 Q by R square. This is the formula for electric field intensity. If the charge should be positive, at that time electric field intensity is away from the point charge. If its charge should be negative, at that time it should be toward the point charge, and electric field intensity should be maximum when it is placed at near the charge. Then next important article we are going to discuss here, that is the electric flux density, and that point is also we have to discuss today's lecture here, that is flux of electric field. Next article is we have to consider the flux of electric field. Flux means we have to say that the number of tubes of induction passing normally through the given area, number of tubes of induction passing normally through the given area when it is placed in an electric field, at that point is called as, say, a flux of electric field around that point. And then electric flux per unit area, that flux per unit area is nothing but the flux density. What is flux density? Electric flux per unit area is called as flux density. Now we have to write the formula, that is, we know that in magnetic field, 12th standard, we have to say that phi is equals to B into A. B is the magnetic induction and A is the area. Similarly here, phi is the electric flux electric flux, so we have to consider d phi E is the electric flux, and then E bar dot ds bar, that is, we have to say that B bar dot A bar. B is the magnetic induction, E is the electric field intensity. A की जगह आएगा surface area ds bar. So we have to write that d phi E is equals to B bar dot ds bar. Here dot product is there, and dot product of two vector is nothing but E ds cos of theta. And then integrating this equation, it gives the equation phi is equals to integration over the S E bar dot ds bar. SI unit of electric flux intensity is considered as, say, voltmeter. Remember, very important point. SI unit of electric flux is what we have, volt into meter. The SI unit of electric flux density is nothing but what? Flux per unit area. This area comes here, so it gets that is electric field intensity. And what is the unit of electric field intensity? That is a voltmeter or Newton per coulomb. Here electric flux density is voltmeter or Newton meter. It should be right that Weber per meter square, and it is equivalent to electric field intensity. These points are very important for electric field flux density. Again we have to consider the another points for, that is electric flux density, and then again we have flux per unit area, that is called as what we have a flux density, and electric field intensity due to a point charge. These points are very important. Remember, write down these points. After the next lecture we are going to study about the Gauss law, is very important statement and its proof. Thank you. Write down all the things.